Okay, we've got an oil spill and it's growing. Let me start by drawing a picture. We said we're treating the oil as a cylinder, so there it is. And now there's going to be a lot of variables here, so we're going to need to keep very good track of our data. What do we know, and what do we want? One thing that we're given is this figure of 2 million liters per hour. And that's a rate, it's a derivative, and to denote it, we're really going to want to use Leibniz notation, because we need to know that it's a rate of what with respect to what. In this case, it's the rate of change of volume with respect to time, so we'll write dv dt. And we're being asked for a different rate. We want the speed at which the edge is moving out. And the center point is fixed, so the speed of the edge is just the rate of growth of the radius, again with respect to time. In other words, dr dt. This is an example of what's called a related rates problem. We're given one rate of change, and we're asked to find a related rate of change. dv dt and dr dt are related because v and r are related. V is always equal to pi h r squared. We also have that h equals 2 centimeters, and we're modeling that as a constant, so we can plug that value in whenever we want. And also, we want this dr dt when r is 250 meters. But here we have to be careful. R is not a constant. It changes as time elapses, so r is really a function of t. And that means we should only plug in for r after we're done taking derivatives. If you plug in before, then you're not allowing r to change anymore, and taking a rate of change of r wouldn't make any sense. Okay, back to the equation. In order to get information about rates, we're going to differentiate this with respect to what variable? Well, both the rate that we want and the rate that we know are with respect to time. So we'll differentiate with respect to t. ddt on the left, ddt on the right. There aren't any t's in the equation, but we're treating v as a function of t and r as a function of t and differentiating implicitly. It's perfectly legal since this equation is true at all times. What you should do now is take a moment and remember how implicit differentiation works. I'll talk to you in a little bit.